Hello! Today we are going to showcase some of the Datagrok's capabilities on an example of a coffee company. Let's imagine we have historical data for sales for all our locations and we want to figure out where to build our next location. To analyze that, let's start with retrieving the data. We will connect to a database. We have already created a connection for it, so we are going to skip that step. Now we are browsing database schema and we found our table that contains sales information. We can browse it just like that in the property panel on the right, and we'll use the pop-up menu to retrieve all of the data to take a closer look at it. Alright, it's done. We've retrieved 13,000 rows. Now we can close data connector. We don't need it anymore. Let's see what we have. So we got about 12 columns containing different information, but we are only interested in a few of the columns. So let's get rid of the rest. And we remove columns with the icon on top. Now it would be good if we could somehow visualize what's happening in here. We get some quick information when just hovering the mouse by the columns, but that's not enough. Anyway, let's try to drill down. First, I want to restrict our analysis to only one state. Let it be New York. To do that, I can select all rows, all matching rows by putting the cursor on the cell containing New York and pressing Shift-Enter. As you see, the context pane has changed and it shows all the selected rows with the available actions. I want to keep these rows. That means the rest were just deleted. Then I want to create a column that would contain the full address of the place. To do that, we click on Add New Column, and now we can simply drag other columns into the field. As you can see, as we type the formula, we get a preview of the results that are refreshed interactively as we change it. So I want it to have street address, city, comma, state. That looks good enough. And I want to call this column address. Done. What can we do with the address column? It's still hard to analyze. Fortunately, the platform recognizes that this column contains addresses and it offers us a special function which is converting address to coordinates. And I've just executed it by clicking on it. Essentially, what is happening, this process is called geocoding, converting address to latitude and longitude, and now we got our results back. Apparently it worked for almost all of the addresses. 38 addresses could not be mapped for some reason. Let's just get rid of them again. I would press Shift-Enter to select similar rows and Shift-Delete to remove them. And we've just deleted 38 rows. Let's see what we can do with that sort of data. Let's open a map. So these are our locations. in the New York State. The platform was smart enough to recognize longitude and latitude, and it put it on the map. Let's see what else we can do with that. We can color code the sales just like that. So the warmer value, warmer color corresponds to bigger sales. As you can see, the shops in Manhattan did quite well. The rest of them, yeah, they sold a lot less. So we have some sort of visual representation, but it's still not good enough. It wouldn't tell us how much would I sell if I built a store somewhere in Hartford or in any other city. Let's see what we can do with that. So now that our database, now that our table contains geographical coordinates, these two columns, latitude and longitude, when we click on a table, another action appears, which suggests to convert coordinates to statistics. So let's do that. Here's the progress bar. And currently we are using US census data to retrieve different demographical data for each of the coordinates. The process will take some time, probably another less than a minute, I think. So while we are doing that, we can explore our map further. All right, we've just gotten back the results. Let's see what we got. Let's open columns. Oh, now we have 44 columns and all sorts of different information containing population density, things like housing unit, location, even elevation, so on and so forth. So this is certainly a lot more interesting now. And we can visualize it on a map as well. Let's see what else we can do with that. So the data is multi-dimensional, and we want to find some model. We want to predict the sales based on that demographics data. In order to make more sense out of this data, we'll try to apply a technique called multivariate analysis. And we want to predict sales based on all numerical values except for latitude and longitude. So it would not let us do that because there are some missing values in the database, in the return data. And the system is smart enough to recognize it and to offer us ways to deal with it. So it offers us to either get rid of the values or impute missing values. Well, missing values imputation sounds a lot more interesting, so let's try that. So we want to impute, let's see what we got here. Yeah, we have very few empty values. Let's try to impute them all. And we want to impute them based on all data again, except for the geographical addresses and sales. we will be using nearest neighbors algorithm. All right, it's done. As you can see, we no longer have empty values in our dataset. And the multivariate analysis dialog does not show us warning anymore. So let's do that. Again, we will try to predict sales based on demographics attributes. Oh, apparently I missed few columns. I probably just forgot to click it. Let's see what they are. Let's do select missing values. Oh, right. We got 9 missing values. We've selected them. All right, let's not impute it this time. I'm just gonna delete it. And they are gone. All right, let's get back to our multivariate analysis. Okay, we got plenty of graphics, which, well, internally it uses a popular tool for multivariate analysis called PLS, Project onto Latent Structures. I will not go into specifics, but essentially it will tell us how different descriptors are correlated and what is their impact on the outcome. So we can browse it a little bit, figure out which descriptors we would want to participate in our predictive model. Also, it shows us the actual prediction that it built using PLS, which is pretty decent, but let's see if we can do better. I'll close that mode for the moment, and we'll try to build a predictive model. So let's train a model. We want to predict sales based on the features that we selected from the multivariate analysis. So just off the top of my head, I want to add population density and few other attributes. We don't really want to add all of that because we don't have that much data and we do not want our model to overfit. All right, so we've selected a couple of features. Also, notice that the system is smart enough to suggest that some of the descriptors are highly correlated, and typically it would make sense to get rid of some of them to improve the model, but we will not be doing it in this step. Let's select a model. So for that, I want to use distributed random forest. I'll leave the default parameters. And we are currently training the model. It will take a little bit and we are done. By clicking on it, we can see what we trained and assess some performance characteristics of the model. Let's build another one. Let's try the generalized linear modeling with the same default hyperparameters. Let's train a model. All right, and it's done. Now let's compare these two models. To do that, we go to predictive modeling, browse models, and we have two models that we've just built. So we want to select both of them by holding Control key and clicking on them. And there is a compare command in the property panel. So here we can compare them side by side and select the one that we want. Also, let's see how well it predicts. Now we want to apply the model that we built to our data set. Well, strictly speaking, in the real modeling we would do differently. We would split the data set into 3 subsets, and then we would train on one subset and test on another and apply to the third one. But for the sake of brevity, we are doing it all against the same data set. And that's a new column that was added as a result of applying the model, the outcome. Let's just see how well we predicted. So we were predicting sales. So that's the real sales, and that's what the model predicted. Which is pretty good. And by the way, many of the viewers support advanced statistical capabilities. For instance, on a scatter plot, by pressing R, you would build a regression line. So it's pretty useful. So nice. Now we have a model that, given demographics characteristics, can predict the sales in that location. But how would we bind it to the actual location? And in the map viewer, we have a special mode called action settings, which lets you perform different actions and bind them to the models. So what we want to do, we want to say show model prediction on double click, and we want to use one of the models that we've just built. And let's see what's happening. So we are double clicking on a map, and it predicted sales 220 in the middle of Manhattan. Another one, 222. All right, that's consistent with these sales. In New Jersey, about the same. Right in the port, in the airport, it would be 0. Above the water would be 0. Let's do a few other things. Queens. So the model seems to be working. Moreover, we can deploy our result as a separate application. So let's put that view on top of everything, and we want to upload it. Let's call it franchise. And we've copied the link. So now it behaves as a full-blown application. There are no menus on top, no property panels, no toolboxes. You are just immersed in an application. And still, by double-clicking on a point, you would see the prediction of the model. So to summarize what we've done in 20 minutes, we've connected to a database, we retrieved the data, we cleaned it, we enriched it by geocoding, by converting addresses to geographical coordinates. Then we visualized it on a map. After that, we extracted demographics from these coordinates. We've also built a predictive model. Along the way, we had to impute missing values. We've also performed multivariate analysis to get a better understanding of our data, since we had over 40 different dimensions. Then we've trained two predictive models. We compared them, we assessed their performance, we selected one. In the end, we've built an interactive application that uses that predictive model to predict sales by just clicking on a map, and we deployed it to end users, all in 20 minutes. Thank you.